All right, listen up. Exam season is officially on. Welcome to your ultimate last-minute crash course. We are going to fly through the entire syllabus, right from the tiniest piece of code all the way up to the cloud. You ready? Let's get into it.
So, let's start with a big question. Have you ever just stopped and wondered, how does one single line of Python, something so small you can type it in a second, scale up to become the entire internet? That's the journey we're on today. We're going to connect all those little details you need for the exam to the huge ideas that basically run our world.
Okay, first things first. Part 1, Python's basic building blocks. And look, everything, and I mean absolutely everything in programming starts right here. If you don't nail this foundation, the rest is just going to feel wobbly. So let's make sure it's rock solid. We're starting at the smallest possible level. Think of a token as the atom of your code. It's the smallest individual piece that has any meaning. Python sees your code as a collection of these 5 things. You've got your keywords, like if or for. Then there are identifiers, which are just the names you make up for things. You've got literals, which are just fixed values, like the number 5 or the text hello. And of course, operators, your plus and minus signs, and punctuators, all the little symbols like commas and brackets that keep everything organized. Okay, eyes on this slide, because this is pure exam gold. This is your classic, guaranteed 1-mark question: which of these names is valid? And the rules are super simple, you just got to remember them. Rule 1, it can't be a special keyword, so break is out. Rule 2, it can't start with a number, so 2021 salary is a no-go. And Rule 3, no spaces, so my file is illegal. Just stick to letters, numbers, and underscores, and you'll be fine. Easy mark.
So once we have our tokens, we can build the basic ingredients of our programs. We call these data types. You have your numbers, your text, which we call strings, and then you have collections to hold stuff like lists, tuples, and dictionaries. Now, the most important idea on this slide is mutability. Some of these, like lists, can be changed after you make them. We say they're mutable. Others, like strings and tuples, are permanent. They're set in stone. We call them immutable. And trust me, knowing that difference is absolutely crucial.
All right, let's move into part 2 and see how this all connects. So now we have our ingredients, right? Our data types. The next logical question is, how do we organize them into something actually useful? Well, this is where data structures come in. And boom, here's that mutable versus immutable idea in action. This is a huge distinction. A list, which you make with square brackets, is like a shopping list. You can add new items, cross things off, change your mind. It's flexible, it's mutable. A tuple, on the other hand, which you make with round parentheses, is like a rule book carved in stone. Once you write it, you cannot change it. It's immutable. The exam loves testing this, so just remember, square brackets are for things that change, round parentheses are for things that stay the same.
Now let's talk about one of my favorite and one of the most powerful data structures in Python, the dictionary. It works exactly like a dictionary you'd have on your shelf. You have a unique key, which is like the word, and a value, which is its definition. So instead of accessing your data with a boring index number like 0 or 1, you can use a meaningful key like name or student_ID. It's an amazing way to keep related bits of information neatly bundled together. Now here's another one that's almost guaranteed to be on your exam. String slicing. If you can get this right, it's 2 easy marks in the bag. So to really understand how this works, we're going to chop up this example string right here. S is equal to kandria.
First thing you have to get your head around is indexing. In Python, every single character in a string gets 2 addresses. You have the forward index, which starts from 0 on the left and goes up. Simple enough. But what's really cool is the backward index, which starts at -1 from the right side. So that last letter A is at index 7, but it's also at index -1. Knowing both of these is the secret to becoming a pro at slicing.
So, how do we actually use those indexes to slice? Well, the syntax is pretty simple. It's just start, end. But here is the most important rule. The one thing you absolutely have to remember. The slice grabs everything from the start index up to, but not including, the end index. So in our example, S of 2:6 starts at index 2, which is n, and it keeps going until it gets to index 6, but it doesn't include it, so it stops at index 5, the I. That's why the output is NDR.
All right, let's zoom out for a second. We've totally mastered what's going on inside a single computer. But how do computers talk to each other? That brings us to part 3, computer networks.
You know, at its very heart, the definition is actually incredibly simple. A computer network is just Two or more devices hooked together so they can share things. That's it. They can share information, they can share resources like a printer, anything. From two laptops in your house to the billions of devices on the internet, it all boils down to this one simple idea.
And here we go. Another classic one-mark question is telling the difference between network types based on their size. It's really all about scale. A LAN, a local area network, is small. Think of the computers in your school or in one office building. A MAN, a metropolitan area network, covers a whole city, like a cable TV system. And a WAN, a wide area network, is massive. It can span entire countries or continents. And what's the biggest WAN of them all? Yep, the internet.
Now, to make all these networks actually work, you need some specific hardware. And these are the 4 pieces you absolutely have to know. A modem is basically a translator for your phone line. A router is the traffic cop of the internet. It connects different networks together. A switch is like a local post office, connecting all the devices inside a single network. And finally, a repeater is just a signal booster. When a signal gets weak over a long distance, a repeater cleans it up and sends it on its way.
So we've seen how data gets made, and we've seen how it can travel around the world. But where does all of it live? Well, that brings us to part 4, the world's biggest library, also known as databases.
The vast majority of the world's data is stored in something called a relational database. And the key word here is relational. It sounds fancy, but all it really means is that the data is organized super neatly into tables, kind of like spreadsheets. And those tables can be linked or related to each other. The RDBMS is just the software, like MySQL, that lets us build and manage this huge, organized library.
So how do you actually talk to this giant library of data? Well, you use a special language called SQL, which stands for Structured Query Language. It is the universal language for asking databases questions. You use SQL to say, "Hey database, can you find this for me?" Or, "Hey, can you please store this new piece of information?" It's the essential bridge between you and all your data.
Now, SQL has 2 main jobs, and this is a really important distinction. Think of it like building a house. DDL, the data definition language, is the architect. It designs and builds the structure of the house, the tables themselves. You use commands like create table to build the rooms. Then you have DML, the data manipulation language. This is what you use to put stuff inside the house. You use commands like insert and update to arrange the furniture and live in it.
So let's look at a real query. It's actually a lot like plain English. Select CNAME, city. That's just saying, show me the customer's name in their city. From customer tells it which table to look inside, and where salary greater than 80,000 is the filter, but only for the people whose salary is more than 80,000. See? Select what, from where, with this condition. It's that logical.
Okay, take a deep breath. We have covered a ton of ground. Now, it's time for the final sprint. Part 5, your exam cheat sheet. This is a rapid-fire review of the absolute must-know concepts. Let's lock it in.
All right, here we go. Let's drill this. Number 1, the difference between mutable data you can change, like a list, and immutable data you can't, like a tuple. Got it. 2, string slicing. Make sure you're comfortable with both positive and negative indexes. 3, networking hardware. Remember, a router connects different networks, a switch connects devices on the same network. And finally, databases. Know that basic select from where structure, and know that DDL builds the house and DML puts stuff in it. You know this stuff.
So there you have it. From a single token of code to a massive global database, we've just covered the entire map. The only question left is, which part are you going to conquer first? Now go ace that exam. Good luck.